Hello. Today we'll be beginning lesson 2 in your workbook, linear equations. The first thing that I would like you to learn or ensure that you understand is the difference between an expression and an equation. An expression does not have an equal sign, 2x plus 1. I can't do anything with that because I don't know what x is. I can't combine them because the one does not have a variable, it doesn't have an x, so they're not like terms. So that's about all that I can do with this. An equation is going to have an equal sign. I would be able to solve this. So today we're going to learn how to solve problems for the variable. We want to be able to figure out what is the unknown. All right, let's try example number 1. Is x equals 4 a solution of the problem 3x minus 1 equals 8? Well, we've done problems similar to this before. What we're going to do is we're going to plug in 4 for the x. So every time I see an x in an equation, I'm going to write 4. So 3x minus 1 equals 8. What did we say x was again? 4. So now we use order of operations. Remember, we always write order of operations on the side of the paper until you're 100% sure that you have it down pat. PEMDAS. 3 times 4 equals 12. We always rewrite the problem. 12 minus 1 equals 11. Does 11 equal 8? No, it does not. So I just draw a line through it. 11 does not equal 8, so this is not a solution. This is not a solution. Let's try it again. Example number 2. Is x equals negative 1 a solution of 2x plus 3 equals 5? Negative 2x plus 3 equals 5. So now, everywhere I see an x, you're going to plug in negative 1. So let's rewrite the problem. Negative 2x plus 3 equals 5. We're going to plug in negative 1. So you have negative 2 times negative 1, which is positive 2. My pen is beginning to act up here. Plus 3. Does that equal 5? 2 plus 3. Yes, it equals 5. It checks. This is a solution. So x equals negative 1 is a solution. Let's do a couple of problems where we have to solve for x and they don't even give us anything to work with. Here's what I mean. Here's the equation. 2x plus 1 equals 9. They don't say is x equals 4 or anything like that. They want you to figure out what is x. So what we have to do is isolate the variable. We're going to isolate the variable. The way we begin that is we use PEMDAS still, but this time we're going to go the opposite direction. Anytime you solve equations, you go the opposite direction, which means you would do addition and subtraction first, then multiplication and division, and so on. All right? So when you're solving equations, you always have to do the opposite of what you see. For example, 2 times x plus 1 equals 9. Well, I have 2 times x and I have positive 1. Well, we already determined we do the opposite of PEMDAS, which means we start with the addition, but we always do the inverse. What is the opposite of addition? It's subtraction. So I'm really going to subtract 1. Don't forget, whatever you do to one side, you have to do to both sides. So let's rewrite this problem. 2x, 1 minus 1 is 0, so that's gone, equals 9 minus 1, that's 8. 2 times x, what's the opposite of times? Division, you're right. So I'm dividing both sides by 2. Trying to get this x by itself so we can figure out what it is. 8 divided by 2, 4. That is our answer. Well, how do you know if your answer is right? One way to know if your answer is right is by plugging the answer back into the problem. So if I were to plug in 4 for x, when I solve this equation, I should get 9. All right, here's what I mean. We just said x equals 4. X equals 4, so I'm going to write a 4. 2 times 4 is 8. 8 plus 1 equals 9. It checks. You always should check your work. When you check your work, you are 100% sure that your answer is correct. Let's try this again. If I was to give you negative 5x minus 3 equals 10. Negative 5x minus 3 equals 10. You always do the opposite of what you see. So we start with addition or subtraction, and the opposite of subtraction is addition. I don't want to get ahead of myself here. Negative 3 plus 3, 0. So that cancels. Let me rewrite this problem. Negative 5x equals 13. All right, negative 5 times x, the opposite of times is division. So I'm dividing both sides by negative 5. And x equals negative 13 over 5. It does not matter if you have the negative at the top or the bottom because it goes to both of them. You just can't write it twice. All right, so x equals negative 13 over 5. Don't forget, you're 100% sure that your answer is right if you do what? Check it. You're right. One last problem. I want to try it one last time because I want to be 100% sure that you have it right. So 3 over 4x minus 7 equals 2. Yes, you see a fraction. Don't roll your eyes. Don't suck your teeth. Don't get upset. All right, we do it the exact same way. So the opposite. So instead of subtracting 7, I'm going to add 7. And I have to do it to both sides. Negative 7 plus 7 is 0. So that's gone. Let's rewrite the problem. 3 over 4x equals 9. Got that fraction there. Got to get rid of that fraction. And the way you get rid of a fraction is by multiplying by the reciprocal. The reciprocal, instead of 3 over 4, I have to flip it and multiply by 4 over 3. So I multiply both sides by 4 over 3. Here's why. 4 times 3 is 12. 3 times 4 is 12. So this becomes 1x. That becomes 1x. So we have 1x because you don't have to write the 1. So x equals 9 times 4 is 36 divided by 3. And I get, what's 36 divided by 3? 12. Yes, you're right. So the answer here is x equals 12. All right. Hopefully I didn't confuse you there, but how do you know if your answer is right? You know your answer is 100% correct if you check it. All right. So I'll check it very quickly for you. I'll have, this is 12. My pen is messing up again. Let's try to fix this quickly here. So we're multiplying 3 times 12 is 36. 36 divided by 4 is 9. 9 minus 7 is 2. That's right. All right. There are more practice problems that you can find in your workbook on pages 15, 16, 17, and even 18. Please go back to your workbook, review those examples, watch this video over, press pause, practice the problems until you have a thorough understanding of how to solve these. Until next time.